All right, so just when you think things couldn't get any more confusing, I go and I give you another way to draw or to write, to describe an angle. Okay? So the new angle is with a north or south point of reference. Okay? So the new format is going to be, you're going to have an N or an S over here. Okay? And then you're going to have an angle measure. And then you're going to have an E or a W. Actually, wait, tap the brakes. Come on, Linsmeyer. West is best. Always on top of the E. What? Yeah, west is best, so W should go on top.
I know, but
But just get over it, okay? All right, so that's what it looks like. Now, that's the format, okay? Side note, don't forget, extra credits are due today, okay? All right?
there was extra.
Okay? So what it means is if you've got south 35 degrees east, okay? So that means that you are going to go straight south, but you're going to go 35 degrees off of south to the east. So that's going to be down here where this is a 35-degree angle. Okay? So that is south 35 degrees east. Now, from that one, we can find the compass rose bearing angle off of that. Okay? So that one is, I got to remember which one that was yesterday. That was this color yesterday. Okay? So that angle is this one here. Okay? So that would be what? What do you got? Like 145 degrees. We can find the unit circle angle. That one was, I think, green yesterday. Oops, I shouldn't have gone blue. Oh, man. Oh, well, we'll fix that. Okay. That's my unit circle angle there, which is how much? What's the unit circle angle for that one? Well, you come up with that. I got to change this color to that color. Oh, look at that. Perfect. I love it when a plan comes together. What do we got for a unit circle angle? 305. We also can have a reference angle off of that one, and that was blue yesterday. And so my reference angle is going to be that one, which is 55. Well, I gotta extend that up. I can't bend over that low. I'm an old man, for cripe's sakes. For crimini's sakes. Okay? So that's 4 ways now to say the exact same angle. Okay? All right, so now you're going to walk me through B all the way down, and then you're going to do C all the way down. Okay, so B, talk to me where it is. Where is my angle for B? So kind of like here, kind of this way right here. Agree with that? Okay, because then this angle here is 80 degrees. Okay, fantastic. So what would my compass angle be? 280. Do we agree with 280 degrees? Bless you. Welcome. Agree with 280? Yep. Unit circle angle would be here. 170. Reference angle would be there, 10. Agree? Yeah? What I'd like you to do now is I'd like you to do C. All right, so I get here, and this is 55. So that ends up being so 55 degrees is my compass rose. Trig ends up being there. So that is going to be 35. Trig is unit circle. Reference also happens to be there. So reference is 35. Agree? Love it. Let's go to work, man. A plane is traveling on a heading of north 65 degrees west for 90 miles. Find how far north and west the plane is from the airport. Now, I don't know about you, but I like to draw myself a picture. Okay? So I'm going to start my picture with the crosshairs. Okay? Because at the origin of my crosshairs is the aeroporte. Then the plane is traveling north 65 degrees west. So that's going to be out here. This angle here is going to be 65 degrees. And it's traveling that for 90 miles. We want to know how far north and how far west. We'll go red. So this would be the north. This would be the west that the plane is from the airport. Yeah. Do I know anything in my triangle? Side note, I could have also have drawn my triangle here. Right? And then had W on top and on the right side. Okay? Could have done it both ways. Okay? So this angle here then is 15 degrees. Yes? Okay? So either way you do it, it's going to depend upon how you do. So let's go north first. So if I'm solving for north, Did I only go to 80?
Yeah.
Yep,
Yeah.
I only went to 80.
Okay.
Guy can make one mistake during the day. I mean, come on. Cripes almighty. Cripes all criminy. Okay? Look. Jumping all over me. Making one mistake. Guy forgets to carry a 1 one time.
Do what Kruger does. And let us throw balls at the teacher.
I know.
So.
I know.
Yeah,
Okay.
he puts a ball out.
Yep, I've
and
thrown
if-
yeah.
And if you do it, and if Kruger gets something wrong, a student will chuck a ball.
Chuck a ball at him. Yep. Okay. All right. So I would go here. I would say the sine of 25 degrees is equal to the north part over 90. Okay. Or if you're on that purpley dashed triangle, then it would be the cosine of 65 degrees is equal to the north over 90. In either case, you're going to get the same answer. So here it would be 90 times the sine of 25 degrees is equal to north, which if I had my calculator, now I have my calculator, that would be on is good, 90 trig sine 25 degrees gets me 38.0356 miles is my northern one. What? I'm throwing it out there when I got on my calculator. Again with the shouting. Hi, caramba. Then over here I would go 90 cosine of 65 degrees is equal to north, and I'd get 38.0356 is my north miles. And Tess would yell at me because I didn't round it to a certain number, even though I rounded it to 4, and she didn't see that. And then we would do the other one. So now we'd have to find west. And so we would say, if we're on the red triangle, we would say now here, then this is the cosine of 25 degrees is equal to west over 90. Okay? We could use tangent, but I'm not a fan of using tangent because we probably rounded our north one, and so then we're going to be off by a little bit. Always go back to hard numbers. So 90 cosine of 25 degrees is going to equal my west component. So 90 cosine of 25 degrees is my west component, and that gets me at 81.5677 miles is my west. Over here, that one would be the sine of 65 degrees west over 90. So 90 sine of 65 is west, which then that gets me 81.5677. Okay? So the plane is 38.03 miles north and 81.57 miles west of the airport. Yeah, buddy? Yeah, buddy. Huh? A ship leaves a port at noon and has a bearing of south 23 degrees east. If the ship sails at 30 knots, how many nautical miles south and east will the ship have traveled by 3 p.m.? This sounds like an awesome problem for you to do.
Debate.
So I'm thinking port. So we're going south and east, so I can go port over here. Okay? So then it's going to travel south and east. So that means it's going to go traveling this way. Okay. Oh, it's only 23, so we can go like this. Okay. So then if I draw in my triangle, well, that's a bad triangle. It's got a little bit of a lean to it. So here would be my 23-degree angle, okay, because it'd be south and then 23 degrees east. If the ship is sailing at 30 knots, 1, that sucker's moving. 2, it goes 90 nautical miles in 3 hours, okay? Because it's noon to 1, 1 to 2, 2 to 3. That's 3 hours. Traveling at 30 nautical miles, so that's 90 nautical miles there. We want to know south. We want to do south, and we want to do east. Okay? Let's do south first. So that would be cosine of 23 degrees is equal to south over 90. So that's going to be 90 cosine of 23 degrees is going to be south. And so that the 90 cosine 23 degrees gets me 82.8454 nautical miles in terms of the southerly direction. Okay. Then sine of 23 degrees is going to equal my easterly component over my 90. So 90 times the sine of 23 degrees is going to be my easterly component, which is going to be I get 35.1658 nautical miles. So the ship is 82.85 nautical miles south and 35.17 nautical miles east of port. Yeah, buddy? Yeah, buddy. All right. Love this one. Okay. So a ship is 300 nautical miles west and 65 miles nautical, it should be nautical miles, south of port. What bearing should the ship sail to reach port? Okay. Now we are ignoring current at this point because that brings in vectors, and that's going to come into play in the next chapter. Okay. So we'll get that next. Okay. So ship is 300 nautical miles west and south. So that means the ship is down here. Port is up here. That completes my triangle. This would be 300 nautical miles. This would be 65 nautical miles. So where are we? Do we want to go from port out to the ship, or do we want to be the ship and we want to go home? We want to go home. Go to your homes. Okay? All right, that's where we want to be. So we're on the ship, so we need this angle right in there, because that's going to be the angle that we need to get back to home, back to port. Okay? How are we going to find it? Inverse of tangent. Yep. Okay. So the tangent of, I'm going to call it my ship angle, is going to be the opposite, which is 300, over the adjacent, which is 65. So my ship's angle is going to be the inverse tangent of whatever that number reduces to be, something a little bit less than 5. Okay? So when we do that, trig inverse tangent 300 divided by 65, and we get, oops, not times, that should be divide by 5, and I get 77.7749 degrees. Yes? Yes? Okay, all right. So that would be, so we could write that as, we could say the ship would have to be at 77 point, we'll call it 77 degrees. That would be its bearing, or,
Go
what?
back, look at your 77.
Oh, because I got two decimal points? Just because it's, you know, what is July 7th of 1977. Or we could say north 77.7 degrees east. The first one is yesterday's method. Okay? The second one is what we just learned today. Good times. Good times. Wait till we throw wait till we throw currents and stuff into it too. Oh, hey, you just zip it over there,